I hope all are here now. You just write down the syllabus for third unit, programming microcontroller. So in that syllabus, from mobile, such notifications will interrupt us. Mechanics of programming, assembly language versus C programming, serial port programming, timer and interrupt programming, and the actual programs for the interfacing of a switch, LED, relay, and buzzer. So this is the official bits from this unit, which we are going to learn in unit number 3. So for that, the first unit, whatever we have seen, a little record, it is required to be recalled for the sake of this programming. That means it will start with the pinout diagram of controller. So actually we are just looking or concentrating at only one controller, and that is 8051. So 8051 is having the how many pins, which pin is used for what purpose, which functions are possible with that 8051. So that we should recall. How to do that? Now onwards, we are going to learn that. How to write a program for simple to complex. And in that, we are going to interface the switch, LED, relay, buzzer. So in this, both hardware and software, the support of both, it is required. So both we will see that hardware means the actually controller and that interfacing peripheral, how we can connect, which pin has to connect to which pin of the peripheral. So that is to be identified. And when to give signal 1, when to give signal 0, that is logic 1, logic 0 to which pin. So that is has to write in the program. That program has to feed in 8051 because that is the controller. So how to make that circuit diagram, and accordingly what program we supposed to store in that controller. So that is to be note while learning this particular unit. Got it? So this is what the contents of this third unit is there. Now we will go with that the as usual we will go with that the content today's. Why students are leaving and joining again and again? What is the problem with them? Okay, so the quiz and the next heading as it has been given 111 instructions. So that is also required. Already we have seen the summary or the brief about all types of the instruction set. But now in detail, one by one, we're supposed to learn these all the instructions which are important for writing the program in 8051. So this is what we are going to see in this session or the next session. So this is, we will start with that the quiz. So if you are able to see, I will just make it zoom a little. So these are the today's questions for you. Okay, great. Just looking at that, you have started to give the answer. Very nice. But the first one is a little bit easy one, but a little thinking is required for the next. second and third. So just read it quite calm and patiently give the answer, the correct answer. For the first, I got that, and second also someone has, okay, she has given the answer. For second, it is true. Okay. What about next? By that time, I will just check that anyone is there on waiting. No one is there. So we continue. Second question is, while reading data from memory, WR bar, actually it is, flag should be logic high. Is the sentence is true or false? That is, this condition must be satisfied or no. The answer I received, that is true. That is, this condition must be there. Okay, we'll have a talk on that. The next, third, for demultiplexing, that is to separate the address line and data lines. Which signal is being used, and that is used in which state? That is logic 1 or logic 0 during the first state of machine cycle. So this is what it has been asked in this question. For demultiplexing, which signal is used and in which state it should be? Either connected to logic 1 or logic 0. So in that way, the answers are expected. So think on that a little, just see the, if you have noted down yesterday, from that easily you will get the answer for this question. So yesterday we have learned a little instructions or the information about timing diagram, machine cycle. So these questions are related to that. Not much we are going to use ahead, but as a knowledge, it should be with you. For third question, can I get the answer? Just observe the yesterday's timing diagram if you are drawn there, and or the PPT if you have gone through. So definitely you will get the answer for this question. All are just jumping to the fourth one, but no one is trying for third one. So are you got the meaning of that third question? That is also I supposed to ask now. Port 0 ला AD0 to AD7 लाईन्स आहेत. तर त्या सेपरेट करण्यासाठी, म्हणजे ऍड्रेस लाईन डेटा लाईन्स पासून सेपरेट करण्यासाठी कुठला तरी सिग्नल वापरतात किंवा पिन असते ती 8051 मध्ये. तर ती पिन कुठली आणि ती लॉजिक 1 ला कनेक्ट करावी लागते का लॉजिक 0 ला सेपरेट करण्यासाठी? सो दॅट इज आस्क्ड इन दिस थर्ड क्वेश्चन. Okay, still no one is trying to give the answer for that. For fourth, let us go for IO read operation. For IO read operation, म्हणजे input output read operation, the status of S1 and S0 should be dash and dash. S1 ला काय पाहिजे आणि S0 ला काय पाहिजे. So one table we have seen in last session in which it was shown. If you are remembering, or if that table or if that PPT in front of you, so you can just check it out. Status for S1 and S0. It is expected for that IO operation, IO read operation in that specifically. Okay, now you got the meaning of that, the fourth one. So one has tried to give the answer, but is it correct? That we will wait for 1 minute and we will go ahead with the answer page. From voice side, no one has tried today. Okay, Pratik has tried. And he has given the answer for first. That is the okay. Correct answer he has given. Sanket also given the no. He has given the attendance at the start only. He has not tried for the attempt in the answer. Sanket Jagtap, if you are there, just write anything in the comment in chat box. If you are not there, so what is to be done? I will do. No issue with that. Sanket Jagtap. Okay, you are there. Fine. So if any point you are not getting from this online, so definitely you supposed to do a little hard work from your side, and afterwards you can contact to any of the subject teacher for any of the doubt. We are here to just solve your queries, or we will give the instructions to you in easy. So don't take it otherwise that from this we are not getting anything, and how to do, what to do, no one is solving our problems. So it is not the case. So think positively, and first try from your side, and even though you will not get that clear concept, so definitely you can contact to that respective subject teacher, definitely during the college hours, because we are here now in the college's maximum faculty members, so you can contact to them. And one more instruction in between, just I am interrupting, but one message just before the this session I have dropped on our group. So one Google form, it is there. So our college is inviting the student to make the participate in reverse engineering. Means if any product, electronic product, definitely, as we are the ENTC student, any product you can deassemble and after that assemble it correctly. म्हणजेच काय की कॉम्प्युटर खोलायचा आणि कॉम्प्युटर पुन्हा बिल्ड करायचा. सो लाईक दॅट की कुठलाही प्रोडक्ट एखादा इलेक्ट्रॉनिक आहे तो डिअसेंबल करायचा आणि पुन्हा तो असेंबल करायचा. So if anyone is interested in such project competition or the participation, so you are welcome. So for them this form is given, so just open that form. त्यामध्ये तुमचे जे आयडिया आहेत की बाबा हा मी हे डिझाईन आहे आणि किंवा एखादा प्रोडक्ट आहे तर तो मी डिअसेंबल करून त्याची नट बोल्ट सगळी खोलून ते डिअसेंबल करून आणि पुन्हा एकदा तो बिल्ड करतोय. त्याच्या आतमध्ये काय काय आहे काय नाहीये त्याच्यावरनं मी स्वतःचा प्रोडक्ट तयार करू शकतो जर मला सुट्टे कंपोनंट मिळाले तर. अशा प्रकारे हा कन्सेप्ट आहे. So if anyone is really interested in this deassembling and assembling, so you are welcome and you can fill that information in that form. आणि कुठला प्रोडक्ट आहे की जो तुम्ही डिअसेंबल करू शकता आणि पुन्हा असेंबल करू शकता, त्याचा फोटोग्राफ तुम्हाला तिथं अटॅच करायचा आहे. So for that, that link is given. So all are informed to just check it out, and interested students can fill that form. Okay. So this is the other information. Let us move towards our session. Now I will go for the answer page. So these are the answers. Third question still no one has attempted. So this is what the answer for the first one, that is one machine cycle is equal to 6 T states. So that is the correct answer. All of students means many has given the correct answer. Second, that is the true. म्हणजे डेटा रीड करताना WR हा फ्लॅग कसा राहिला पाहिजे, तर लॉजिक 1 लाच राहिला पाहिजे. तो लॉजिक 0 होऊन चालणार नाही, कारण रीड राईट वेगवेगळ्या ऑपरेशन्स आहेत आणि ऍट अ टाइम इट इज नॉट पॉसिबल टू रीड as well as write. So this is the true statement. The third one, that is to demultiplex 80 to 87, ALE signal goes high. ALE signal goes high during first T state of machine cycle. Now you can remember the waveform, whatever we have seen in the last session. That is for the first cycle only that ALE signal went high. फक्त एका पहिल्या टी स्टेटला हा सिग्नल हाय झाला होता आणि त्याच वेळेस ऍड्रेस फेच केला होता. So just if it is there, so see afterwards that the how it is there. So this is the answer, ALE signal आणि तो हाय झाला पाहिजे फक्त पहिल्या टी स्टेट. पुन्हा मग तो it will use for the data carrying. And the fourth one, that is for IO read operation, S0 आणि S1 चा status, that is S1 comma S0 is equal to 1 comma 0. So that answer I got. So this is what the answers for these questions, whatever we have seen in this quiz. Now we will move to the start of the third unit. So this is what the problem it is with mobile. Okay, not sure. So the first we will go with the if you have gone through the content, today's content. So in that I was written 111 instructions. So they are nothing but the 5 categories we have seen for the instruction set. So which are these? Anyone is remembering? So 2 are you can observe on the screen, but which are the others you are remembering? And tomorrow onwards, that the pinout diagram and upcode sheet that should be there with you as a soft copy, so that whenever we are writing any program or learning the program, simultaneously you're supposed to check out from that upcode sheet of the pinout diagram which pin is there and how to connect, because we are learning the interfacing. So that time it is required which pin is there from that 40 pin IC. So this is what you can see on your screen, that the arithmetic instruction, branching instruction, logical instruction, Boolean or bitwise instruction, and data transfer instruction. So this is only what today we are going to read or we are going to learn. So if you are afterwards I will share this PPT to you, so you can check it out that how many instructions are here under each category. So So in arithmetic, there are 24 instructions. For logical, 25. For branching, it is 22. For Boolean instruction, there are 12 instructions. And for data transfer, there are 28 instructions. So in this way, total 111 instructions are here in front of you. And the use of each one, they are groups actually, but the functioning is different. Means add A, add B, add R1, add R2, add R3, like that. The different instructions are there, but their functioning is the same one. That is the in group. So in that way, this is bifurcated. And if you are looking for the first slide in this, that is the arithmetic operations. So few of the instructions we have seen for example, but here each and every instruction we supposed to learn it out. Additionally, the description is also given in the slide. So one by one we will see that what it is and what it is doing. So if you are looking the first arithmetic instruction, that is add a comma rn. Rn means r to the base n. It is like that. It is not the any name rn. So this n stands for 0 to 7. That is R0 to R7. We have seen that in register bank, RB0, RB1, RB2, RB3, each one is having the 8 registers. That is from R0 to R7. So any value we can put here and the instruction will become, this is the syntax they have given. And it's a description. So if you are putting the 1, n is equal to 1. So the instruction will become add a R1. Add a R1. So what is the meaning of that? So definitely the add stands for the addition, arithmetic operation. So what it is doing? So it will add the value stored in R1 register. What? This will add the value stored at R1 register with the accumulator. With the accumulator. Because if you are observing, A stands for accumulator. A is used maximally for the arithmetic operation. And B is also there, na? B is also there, the register, which is only used, listen carefully, B register is only used in multiplication and division. Nowhere else this register B is being used in the total programming of 8051. फक्त मल्टिप्लिकेशन आणि डिव्हिजन करताना रजिस्टर बी चा उपयोग केला जातो. बी चं मल्टिप्लिकेशन ए शी आणि जे आलेले उत्तर आहे ते कशात स्टोअर होणार? डेफिनेटली इट विल बी स्टोर्ड इन accumulator A. तसंच डिव्हिजन मध्ये पण भागाकार कशात स्टोअर होणार? तर accumulator मध्ये A मध्ये. So like this, the register B is having the limited scope, that is for 2 instructions only, that is multiplication and division. So we will see small programs for multiplication and the division. So actually the hands-on must be there. That time only we will get the exactly how the output is look like and what we have written, is it correct or wrong? Because whenever you are compiling the program, it is giving the errors. So what type of errors are these? How we can correct the errors? So definitely the practical, when we are going to see or we are going to handle the actually practical, that time only this we will come to know. But right now, only the theoretical part we are going to see here. So this is what the first instruction of add, that is the add a rn. So in simple description they have given, that is add register to accumulator. पण ऍक्च्युली रजिस्टर ऍड होत नाही, तर त्या रजिस्टरला जी व्हॅल्यू आहे ती accumulatorच्या व्हॅल्यूशी ऍडिशन होते आणि जे उत्तर आलेलं आहे ते ए मध्ये स्टोअर होतं. So this is the what meaning of this first instruction. After that, add a direct. Add a direct. So what is the meaning of that? So it is the another form of that particular above instruction. आपण वेगवेगळे ऍड्रेसिंग मोड्स बघितलेले आहेत. डायरेक्ट ऍड्रेसिंग मोड, इमिजिएट ऍड्रेसिंग मोड, indirect addressing mode. So from that, this is what the direct, it is giving the memory location. एक मेमरी लोकेशन दिलं जातं आणि त्या मेमरी लोकेशन वरचा डेटा म्हणजे व्हॅल्यू, द व्हॅल्यू ऍट दॅट ऍड्रेस इज ऍडेड विथ द व्हॅल्यू ऍट accumulator आणि answer will be stored in accumulator. Like this is the meaning of this one, that is add direct byte to the accumulator. Third one, that is the add a at the rate ri. Again this ri, I stands for that the 0 1 2 3 the values. So here you can read the description that add indirect RAM to the accumulator. Indirect RAM to the accumulator means what? rn किंवा ri रजिस्टर मध्ये जी व्हॅल्यू स्टोअर केलेली आहे ती आहे ऍड्रेस, ती आहे ऍड्रेस. आणि त्या ऍड्रेसवर ऍट द रेटचं मिनिंग काय सांगितलं होता? एनीवन हॅज रिटन ऍट द रेट? इनडायरेक्टली असेल तर लिहून घ्या कुठेतरी. ऍट द रेटचं मिनिंग काय तर इनडायरेक्टली. तर त्या रजिस्टर मध्ये जी व्हॅल्यू आहे तो एक ऍड्रेस आहे आणि त्या ऍड्रेसवर जी व्हॅल्यू आहे त्याची ऍडिशन करायची. कोणाशी करायची? तर accumulator मधल्या डेटाशी ऍडिशन करायची. आणि जे उत्तर येणार आहे ते कुठे स्टोअर होणार आहे? तर परत accumulator मध्ये स्टोअर होणार आहे. So this is what the meaning of this instruction, that is at the rate ri. After that we have seen that one, add a comma, just make it a little zoom, hash data. तर ही कुठल्या प्रकारची इन्स्ट्रक्शन आहे? ऍड्रेसिंग मोड. इट इज इमिजिएट ऍड्रेसिंग मोड. हॅश म्हणजे काय? डायरेक्ट डेटा. That also we have discussed in earlier sessions. Hash means direct data. Add immediate data to the accumulator. Means what? Adds the data given by the program with the value stored in accumulator and store the result in accumulator. For example, hash 45h असा असतं. तर 45 हा डेटा आहे, तो accumulator मधल्या व्हॅल्यू बरोबर ऍडिशन करायचा आहे आणि जे उत्तर येणार आहे ते पुन्हा एकदा accumulator मध्ये स्टोअर करायचं. So this is what the instruction add a comma hash data, the meaning is. So again it gives the next one. आता ह्याच्या पुढच्या जर इन्स्ट्रक्शन बघितलं तर सेमच आहे. add 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 add. आता add c add c add c add c. तर त्याचा मीनिंग पण आपण बघितलेला आहे. c stands for the carry. c stands for the carry. So by considering the carry, we have to write the instruction add C. बाकी वर्किंग सेम, फंक्शन सेम, पण हेक्स कोड मात्र वेगळा, अपकोड मात्र वेगळा, because the instruction is different, because it is considering the carry. आणि कधी लागतं नॉर्मली बाय डिफॉल्ट फक्त ऍड इज इन्स्ट्रक्शन वापरली जाते, परंतु ऍड सी ही इन्स्ट्रक्शन कधी वापरली जाते तर 8 बिटची ऍडिशन आहे, नीट आहे का? The addition is of 8 bit and from the lower 4 bit carry had generated. From lower 4 bit, that is the 4th bit, carry is being generated and that will goes to the 5th column. So that time this carry flag it is required. That is the add C instruction is required. Otherwise normally for the regular addition add instruction is used. Similarly now for the subtraction, SUBB space A comma RN. So again n stands n's value ranges from 0 to 7. So here what is the meaning of this? So subtract register from A with borrow. So now in this subtraction जसं add आणि add C होतं तसं subtraction मध्ये नाहीये. So it is only SUBB म्हणजे compulsory with borrow अशी instruction आहे subtraction साठी. So how it works? So for example it is given that is SUBB A comma RN. ही काय करते? Subtract the value stored in RN. म्हणजे त्या RN मध्ये जी व्हॅल्यू आहे ती सबट्रॅक्ट होते कशातून? व्हॅल्यू ऑफ अक्युमुलेटर. अक्युमुलेटर मध्ये जो डेटा आहे त्याच्यातून ही व्हॅल्यू मायनस होते आणि रिझल्ट इज स्टोर्ड अगेन इन अक्युमुलेटर. अक्युमुलेटर मध्ये हा डेटा स्टोर केला जातो. सो दिस इज हाउ व्हाट द meaning of this arithmetic instruction, that is subtraction. या इन्स्ट्रक्शन्स घेऊन ऍक्च्युली आपण पुढच्या सेशन मध्ये छोटे छोटे प्रोग्राम बघणार आहोत. और we will try here also, that is how we can write the program for addition, for subtraction. So that also we are going to learn, because the title of this unit it is programming the controller. So that we will, but for that कुठल्या कुठल्या इन्स्ट्रक्शन्स आहेत 8051 मध्ये त्यांचा उपयोग कशासाठी होतो, सो दॅट वी शुड नो फर्स्ट बिफोर द प्रोग्रामिंग. परत पुढची जी आहे सबट्रॅक्शन नंतर तर INC. INC स्टँड्स फॉर द इन्क्रीमेंट. जर इन्क्रीमेंट करायचं असेल एक न तर त्याच्यासाठी दिस INC इन्स्ट्रक्शन इज देअर. मग INC बरोबर वेगवेगळे ऑपरँड वापरलेले आहेत, जसं INC A, INC RN, INC डायरेक्ट, INC @RI अशा प्रकारे. द सेम इट इज ऍप्लिकेबल फॉर डिक्रीमेंट. 4 इन्स्ट्रक्शन इन्क्रीमेंटच्या, 4 इन्स्ट्रक्शन डिक्रीमेंटच्या, 4 इन्स्ट्रक्शन ऍडच्या, 4 इन्स्ट्रक्शन ऍड सीच्या आणि 4 इन्स्ट्रक्शन सबट्रॅक्शनच्या. How simple to remember, you just note it down. प्रत्येक ह्याचे 4 आहेत आणि प्रत्येकचं ऑपरंड इज सेम. ओनली द अर्लियर पार्ट इट इज गोइंग टू बी चेंज. ऍडच्या ऐवजी सब, सबच्या ऐवजी ऍड सी, ऍड सीच्या ऐवजी INC, INCच्या ऐवजी DEC, that is decrement. So what it is doing actually, so it is nothing but increasing the value by 1. Increasing the value by 1. Increment A म्हणजे अक्युमुलेटर मध्ये जो काही डेटा आहे तो एक न इन्क्रीमेंट होणार आणि इन्क्रीमेंट झालेला डेटा कुठे स्टोअर होणार हा पण प्रश्नच आहे. So the incremented data, that is output data, is also stored in the accumulator itself. म्हणजे पहिला डेटा गायब होणार. This is what the result will be overlapped on that earlier data. अशी आहे INCA. INCRN. INCRN. So N stands from 0 to 7. तर काय याचं मिनिंग होईल? INCR1 अशी जर कमांड दिली तर काय होईल? जस्ट थिंक ऑन दॅट फॉर 1 मिनिट. INCR1 त्याचा काय अर्थ होतोय? इथं त्यांनी शॉर्ट मध्ये दिलेले की इन्क्रिमेंट रेजिस्टर, पण एक्झॅक्टली काय होणार इन मोर डिटेल? INCR1 अशी मी कमांड दिलेली आहे. Just think on that. Keep your answer with you. I will give the answer. Then just match the answer. You are also thinking the same or what? So registers are available from R0 to R7. So I have given the instruction INC R0. So काय होईल? The answer is it increases the value stored in R0 register by 1. म्हणजे त्या R0 register मध्ये जो काही डेटा आहे तो 1 न इन्क्रिमेंट होणार आहे. Got it? तर आता नेक्स्ट सिंपल क्वेश्चन की त्या R0 रजिस्टर मध्ये माझा डेटा आहे 04 बिफोर द इन्स्ट्रक्शन. आफ्टर द इन्स्ट्रक्शन काय डेटा असेल हो? त्यात काय म्हणा, सोपं तर आहे की. So it is an increment. So if the data is 04, so definitely after the increment it will be 05. Very good. Now in the same way, if I will ask the data before the instruction is 0f, just note it down. If the data in R0 is F0f and after the instruction INC R0, the result will be dash dash. काय उत्तर लिहिणार? So I am expecting in the chat box. R0 मध्ये 0f हा डेटा आहे आणि मी इन्स्ट्रक्शन्स दिलेले आहे INC R0. तर ह्या इन्स्ट्रक्शन नंतर रिझल्ट काय मिळेल? So definitely it will increment, but what answer it will give or what will be the result, that I want to know from you. So take 1 minute and try to give the answer. What happened? No one is trying for answer. So this is the starting lecture, so usually I get a little bombarding like that. But if you are going ahead, so while we are going to write the program, so definitely you will get automatically the interest in that, all the instructions and how we can write or how we can modify the program in that way. But the basic operation only I have asked is 0f हा डेटा आहे R0 मध्ये आणि मी इन्क्रिमेंट R0 केलेला आहे, कमांड दिलेली आहे, तर मला रिझल्ट काय मिळेल? Still no answer. So those who are familiar with C programming, at least from them I am expecting the answer, because these are the logical questions been asked. पहिली व्हॅल्यू आहे 0f, इन्क्रिमेंट कमांड लिहिलेली आहे, तर त्यानंतर काय मला उत्तर मिळेल? व्हॉट विल बी द रिझल्ट? So definitely the data will be in hex. 0fh हा डेटा आहे, तर इन्क्रिमेंट झाल्यावर काय होईल? Okay, at least one answer I got, and that is the correct answer. So that will be 10h. 0f नंतर काय असतं? काय असतं इन द सेन्स 0f मध्ये एक ऍड केल्यावर काय येतं? So the answer is 10h. So definitely with that the INC we will get the answer 10. Okay, the next one. So the increment is done. The decrement in the same way it is going to happen. After that, the MUL. MUL. This is the only one command, means the specific command used for multiplication. For multiplication. आणि लिहिताना कसं लिहायचंय, that also we supposed to remember, because many students are doing that mistakes. MUL space AB. MUL space AB. So AB, there is no space, no comma, nothing, the star like that in between. So MUL space AB continuous. So here, as I told before some time, that register B is used. Register B is used here. For what purpose and how? So the way is that multiply A and B. So actually the A is not getting multiplied with B. The values in A is multiplied with values in B. This is what actual description is. Get it? The values of A and values of B, they are getting multiplied, and the answer is stored in, correct, in the accumulator itself. In the accumulator only the answer is going to be stored. So that is the multiplication. Only one command is there. For division, it is there, the div AB. Div AB. The same way, divide A by B. This is very important. Divide A by B. A ला B न भागायचं, B ला A न नाही. So that is what the fact we supposed to learn. A मधल्या डेटाला B मधल्या डेटानं भागायचं आहे. फॉर एक्झाम्पल, A मध्ये 16 आहे आणि B मध्ये 4 आहे. तर 16 divided by 4, that is the answer is 4. In this way, this division is going to happen. And the last one, that is for the decimal adjustment. DAA. DAA. Normally it is not been used anywhere, but in a if you are remembering the 7-segment display, आठवतोय 7-segment display, तर त्याच्यामध्ये एक डॉट असतो बघा. That is what the decimal adjustment की 11.11 का 1.11. So this shifting of this decimal point, so that is handled by this particular DAA. म्हणजे accumulator मधला जो डेटा आहे त्याच्यावर तुम्ही हा decimal point adjust करू शकता. So how to do that? So by taking one example only, we supposed to learn that practical time. So that time we will see. Right now you just note down or remember this. This is used for the decimal adjustment of accumulator. So normally it is being used in the BCD addition or the operations related to BCD numbers. Got it? So that also it is important for BCD addition or BCD operation. This particular instruction is used. So such sentences can be asked in the MCQ also, that for BCD addition dash dash is a special instruction which can be used for the decimal adjustment. So that time your answer is should be this DA space A. So these are the few instructions from arithmetic category. Now similarly you can see the next, that is the branching. I will make it so. So for branching there are 22 instructions. There are 22 such instructions and the list it is in front of you. ब्रांचिंग म्हणजे काय की एका प्रोग्राम मधून दुसऱ्या प्रोग्राम मध्ये जायचं. दॅट इज नोन ॲज द ब्रांचिंग. मग कसं करायचं? सो द मेन इन्स्ट्रक्शन्स इन दिस ब्रांचिंग इट इज कॉल. कॉल हे एक ऑपरेशन आहे की ज्याच्यातून तुम्ही दुसरा प्रोग्राम बोलावू शकता किंवा दुसरा प्रोग्राम तुम्ही सब रूटीन तिथं रन करू शकता. कॉल. रिटर्न म्हणजे जर तो सब रूटीन चालू आहे तर त्या सब रूटीन मधून मेन प्रोग्राम मध्ये यायचं आहे. सो फॉर दॅट रिटर्न दॅट इज द ऑपरेशन इज देअर. त्यानंतर ब्रांचिंग ऑपरेशन आहे जम्प. कधी कधी लागतं की जर ऍडिशन 5 आली तर डायरेक्टली जम्प टू द सेकंड प्रोग्राम. जर ऍडिशन 10 आली directly jump to the 15th program, like that. So this jump operation in various categories it can be utilized. So main it is call, return, jump अशा instructions आहेत. आणि त्याचबरोबर नेक्स्ट आहे ते stack pointer. So that is the different one, but it is comes also in branching. Stack मध्ये पण तसंच होतं की push आणि pop ह्या दोन इन्स्ट्रक्शन स्टॅक रिलेटेड आहेत आणि दे आर यूज दॅट इज द फर्स्ट इन लास्ट आउट. इन दॅट मॅनर इट इज गोइंग टू बी वर्क. सो हियर व्हॉट इज दिस कॉल, हाऊ इट इज बीन यूज्ड? सो वी विल कॉन्सन्ट्रेट ऑन दॅट वन. सो फर्स्ट instruction, if you can see here, a call address 11, a call address 11 आणि त्याच्यात खालची आहे L call address 16. L call address 16. त्याचं डिस्क्रिप्शन पण वाचा. दॅट इज absolute subroutine call. Absolute subroutine call. आणि खालचं जे आहे ते लॉंग सबरूटीन कॉल. तर काय याचा मीनिंग आहे? दोन्हीचा मीनिंग फंक्शनिंग सेमच आहे, फक्त डिफरन्स काय तर ऍड्रेस 11 आणि ऍड्रेस 16. ऍड्रेस लाईन्स 11 आणि ऍड्रेस लाईन्स 16. ऍड्रेस लाईन्स 11 म्हणजे त्या मेमरीचा साईज किती असेल. Have I asked something different? No. Address line 11 म्हणजे त्या मेमरीचा साईज किती असेल. Can anyone give the answer for this? So for that, you should recall that the earlier sessions, one slide, it was there that 4K ROM, 4K RAM, त्याच्यात vertical, horizontal lines, and from that, how to identify or how to calculate the address for 4K RAM or 2K RAM or 64K RAM, like that. So can I expect the answer? Eleven address lines म्हणजे 2 raised to 11. 2 raised to 11 म्हणजे 2K ROM किंवा RAM. Got it? 11 address lines म्हणजे A0 to A10. बरोबर. तर 11 ऍड्रेस लाईन म्हणजेच त्या मेमरीचा साईज होतो 2 किलोबाईट. जर तुमचा ऍड्रेस हा म्हणजे जिथून डेटा फेच करायचा आहे, कॉल ही इन्स्ट्रक्शन कशासाठी आहे तर एखादा प्रोग्राम दुसऱ्या मेमरी लोकेशन मधनं कॉल करायचा त्यासाठी. त्याची जर साईज 2 किलोबाईट असेल तर ही इन्स्ट्रक्शन वापरली जाते, ए कॉल ऍड्रेस 11. आणि जर जी मेमरी कनेक्ट केलेली आहे ती 64 KB ची आहे तर त्याला 16 ऍड्रेस लाईन्स लागणार, म्हणून एल कॉल ऍड्रेस 16. तर फक्त एवढाच डिफरन्स आहे, दोन्हीचा उपयोग तेच कॉल करायसाठी, कॉल द सबरुटीन. फक्त मग 11 ऍड्रेस लाईन वापरून करायचा का 16 लाईन वापरून करायचा. सो दॅट इज डिसाइडेड बाय दिस पर्टिक्युलर कॉल इन्स्ट्रक्शन. सो दिस इज द यूज ऑफ कॉल इन्स्ट्रक्शन. रिटर्न सेम तसंच आहे. RET that is returns the control from subroutine आणि RETI that is the return the control from interrupt subroutine. मग आता हा नॉर्मल रिटर्न का इंटरप्ट रिटर्न, so that depends on that की what the external memory it is connected or not. कारण interrupt we have seen there are main 5 interrupts. त्यातला एक्सटर्नल इंटरप्ट म्हणजे की दुसऱ्या प्रोग्राम मधून हार्डवेअर मधून दिलेला इंटरप्ट. मग त्या हार्डवेअर मधून दिलेला इंटरप्ट वेगळा, सॉफ्टवेअर मधून दिलेला इंटरप्ट वेगळा. त्याच्यातून जर रिटर्न होत असेल तर सो इट विल यूज द RETI. So this is what we have talked about this branching instruction. So the next few instructions are remain, but as the time passes, so we will see the coming session. So today we will stop here. So I hope this a little things you got from this the instructions, because 111 instructions are there. So all the instructions we supposed to learn, that is get it. So you also try from your side to concentrate here, or after the sessions also you can work on that की कुठली instructions काय अर्थ होतो, कसा अर्थ होतो, so that whenever we are going to see here, so you can match and you will get the actual use of that each and every instruction, how we can use it in the program. So that is also required. Now you can start to put your attendance in the chat box. That will be recorded. So we will stop here. I will stop the presentation. You can give the attendance and you can leave. And just think on that reverse engineering ideas project. You just go through that the form which is given on the group. Thank you.